Hello everyone, continuing with the exercises from the applying. This is exercise number 4, the game of life. And in Conway's game of life, some cells of a grid are dead and some are alive. Two cells neighbor each other if they are adjacent horizontally, vertically, or diagonally. At the end of each day, a dead cell becomes live if it had exactly 3 live neighbors during the day. And the live cell becomes dead unless it had exactly 2 or 3 live neighbors during the day. In the following grid, a star indicates a live cell. The question is, how many live cells will there be the next day? Well, this is the original text with no annotations, and I have written some letters and numbers to identify columns and lines in the grid. On the right hand, I have a copy of the grid to provide an answer to the exercise. Okay, so let's first identify our rules, which are these right here. Okay, and let's reread them. A dead cell becomes live if it had exactly 3 live neighbors during the day. So let's first pay attention to dead cells. Okay, so C1 is a dead cell and it has 1 and 2 neighbors. So next day, this cell will remain dead. Cell D1 has just one neighbor, which is this one. So by next day, this cell will remain dead. Cell E1 has just one neighbor as well, which is this one. So this cell will remain dead. The second line, let's start with A2, which has 1, 2, and 3 neighbors. So this cell will be live next day. And cell B2 has 1 and 2 and 3 neighbors as well, live neighbors. So this cell will also be live next day. For cell C2, we have 1, 2, and 3 live neighbors. So this cell will be live. And cell E2 has just 1 and 2 live neighbors. So this cell will be dead. Let's move to cell A3, which has just one neighbor. So this cell will be dead. Cell C3 has 1, 2, 3, and 4 live neighbors. So since a dead cell needs exactly 3 live neighbors, this cell, this C3 cell will be dead. The same happens to cell D3 because this cell has 1, 2, 3, and 4 live neighbors. So D3 will be dead as well. Let's move to the fourth line, and cell 4 has 1 and 2 live neighbors, so this cell will be dead. Cell B4 has 1, 2, 3, and 4 live neighbors, so this cell B4 will be dead as well. And cell E4 has 1, 2, and 3 live cells, exactly 3, so this cell will be live by next day. In the last line, for cell B5, it has 1, 2, and 3 live neighbors, so this cell will be live. And cell D5 has 1, 2, 3, and 4 live neighbors, so this cell will be dead. I am gonna change the color, and let's now pay attention to live cells. And a live cell becomes dead unless it had exactly 2 or 3 live neighbors during the day. So for cell A1, this cell has just 1 live neighbor, so this cell will be dead by next day. The same will happen with cell B1, since this cell has just 1 live neighbor, which is A1. Now, cell D2 has just 1 neighbor, so this cell will be also dead. And cell B3, which is this one, will be dead by next day since it has just 1 neighbor. We have then cell E3, which has 1 and 2 live neighbors, and that is enough for this cell to live. So cell C4, which is this one, has 1, 2, and 3 live neighbors, so this cell will be live. And let's pay attention to what happens with cell V4, because it has 1, 2, 3, and 4 live neighbors, so that means that cell D4 will be dead by next day. On the last line, let's start with A5, which has no neighbors, so this cell will be dead. Cell C5 has 1 and 2 neighbors, and that is enough for this cell to live. And cell E5 has just 1 live neighbor, so this cell will die. We have a total of 3, 4, 5, 6, 7, 8 live cells by next day, so that means that our answer is letter C. That's it for today.